Hello, Alvin ISD mathematicians. Today we're going to be learning about converting units within measurement systems, which is our 6th grade skill of 6.4H. Now, how will we be doing that today? Well, today we're going to convert those units within measurement systems by using proportions, ratio tables, and unit rates. Notice the phrase unit rates is bolded and underlined. This is something that is new to us in 6th grade, so we're going to talk about that word a little bit. A unit rate is a comparison of two measurements in which one of those terms has a value of 1. So when we look at our examples, we have a $15 hourly wage. Well, since it's hourly, that means I make $15 in 1 hour. So since 1 is part of my comparison, that makes it a unit rate. Same thing with 55 miles for 1 hour. Or the conversion factor of 1 foot is to 12 inches. Because we have a 1 in there, it makes it a unit rate. We have 82 words per minute is an example, and then 3 avocados for $1. Some non-examples, or something that is not a unit rate, is 20 cupcakes for $10. Neither of the values in that comparison or that ratio is 1. 80 miles per 2 hours, again, does not have 1 in the comparison. 1/2 of a foot is equal to 6 inches. While this is still the same ratio, or an equivalent ratio to our 1 foot and 12 inches, since 1 is not a part of that comparison, it is not a unit rate. And then lastly, 4 pairs of socks for $16, again, does not have 1. We are going to be using our STAR reference material sheet for this entire lesson. And notice when I said what we were doing today, I spoke about how we were going within measurement systems. What that means is we will be staying either in the metric system or the customary system. So we'll be converting between miles, yards, feet, and inches, or between kilometers, meters, centimeters, and millimeters. We're not going to cross between customary and metric. This is actually something that you'll learn next year in 7th grade math. So how are we going to know that we've hit the mark or that we've actually learned it? By the end of today's lesson, you're going to be able to answer the following question. A park has a field that has a perimeter of 6,615 feet. What is the field's perimeter in yards? So we're going to move on to our first warm-up. We're going to kind of get our brain going today. So we have pears that are on sale for 5 pounds for $8. We want to use the following ratio table to find out how many pounds of pears that we can buy for different amounts of money. So we want to find how much 10 pounds would cost, and then how much 1 pound would cost. So pause the video and take this time to think numerically. And notice it said ratio table, so we're going to be using our multiplicative thinking. When you know how much 10 pounds will cost and how much 1 pound will cost, please resume the video. All right, welcome back, you guys. Notice I filled out my ratio table with my thinking. So I knew that if $8 gave me 5 pounds, then I could double that or multiply it by a factor of 2, so that 10 pounds would cost me $16. Well, now that I knew the price of 10 pounds, I could very easily divide by 10 to find the cost for 1 pound. So 10 divided by 10 is a value of 1, because anything divided by itself is 1. And then $16 divided by 10 gave me $1.60. All right, our first example. So we want to know how many inches are in 3.5 feet. So we are going from inches to feet, which means I want to look at my STAR reference material sheet. So we're looking at length. So on my STAR reference materials, I go to where it says length, and then I find the conversion factor that I need. Notice my conversion factor has a 1 in it. This means that this is a unit rate. because 1 is a part of the comparison. So if I know that 1 foot is equal to 12 inches, I'm going to make a ratio table. Now I'm going to label it with what I'm converting. So I'm converting between feet and inches. And I'm going to put the ratio that I know. Well, I know the conversion factor of 1 foot is equal to 12 inches. Well, now I'm going to put what I'm trying to find. I'm trying to find how many inches there are in 3 1/2 feet. Since I'm building a ratio table, I know that I can use my multiplicative thinking. So if 1 foot is 12 inches, then I know that I can find 3 feet by multiplying both sides of my ratio table by 3. So 3 feet is equivalent to 36 inches. But I want to know how many inches 3 1/2 feet are. So if 1 foot is equal to 12 inches, then half of a foot would have to be 6 because I'm dividing by 2 on my ratio table. And if I have that 3 feet is 36 inches and half a foot is 6 inches, then altogether the 3 1/2 feet gives me 42 inches. All right, our example 2. An African bush elephant weighs 5 1/2 tons. How many ounces does the elephant weigh? So I'm going from tons all the way to ounces. So I'm going to look at my star chart. For me to go from tons into ounces, I need to go through pounds first. So I'll actually be using both of these unit rates for converting. So I have 1 ton is equal to 2,000 pounds, and then 1 pound is equal to 16 ounces. So my conversion plan is to go from tons to pounds, and then from pounds to ounces. So I'm going to set up my ratio for tons and pounds. And I'm going to write my conversion factor that I know. I know that 1 ton is equal to 2,000 pounds. But I need to figure out how many pounds 5 1/2 tons are. So just like our thinking on the prior slide, if 1 ton is 2,000 pounds, then 5 tons I can find out by multiplying both sides of my ratio table by 5. So 5 tons is equivalent to 10,000 pounds. And now I just need to figure out my 1/2. If 1 whole ton is equal to 2,000 pounds, then 1/2 of a ton would be equal to 1,000 pounds. Again, which means if I know what 5 pounds is equal to in pounds, 5 tons is equal to in pounds, and I know what half a ton is equal to in pounds, then I can easily figure out what 5 1/2 tons is equivalent to. So 5 1/2 tons would be equivalent to 11,000 pounds. So now that I know the elephant's weight in pounds, I need to convert my pounds into ounces. So I'm going to set up my second ratio table. So I'm starting with my pounds, and then I'm going to ounces. And my unit rate that I know, or my conversion factor, is I know that 1 pound is equivalent to 16 ounces. So, and I'm trying to figure out how many ounces 11,000 pounds is equal to. So again, since I'm working with a ratio table, I can either work on the outsides of my ratio table, or I can work across. So I see that to get from 1 to 16, I can multiply by 16. So then to find my missing value in ounces, I can multiply 11,000 by 16. So I'm going to come over here and show all of my work. 11,000 multiplied by 16. So I get a total of 176,000 ounces. So our African bush elephant weighs 176,000 ounces. That is a lot of ounces. All right, our next example. In order to keep the lemonade from tasting too sour, because nobody likes that, Jolene has to mix it with water. So she uses 12 cups of water, and we want to figure out how many gallons that is. So we are going from cups all the way to gallons. So my first stop in my problem-solving process is to look at my STAR reference materials. And again, I'm going from cups to gallons, which means I'm going to have to actually stop through a couple of my conversion factors. So I have written all of the conversion factors that we'll need. We'll need that 1 gallon is 4 quarts, 1 quart is 2 pints, and 1 pint is equal to 2 cups. When I think about this, if 1 pint is equal to 2 cups, then 2 pints would need to be equal to 4 cups, which means that 1 quart is equal to 4 cups. And if 1 quart is equal to 4 cups, then 4 quarts would be equal to 16 cups, which means that I have 1 gallon is equal to 16 cups. So now, instead of having to go through multiple conversions, I've used my multiplicative thinking to be able to streamline my conversion process. So I'll make my ratio table, and I have cups and gallons. And I know that 16 cups is equal to 1 gallon, but we only use 12 cups, so I need to know how much or how many gallons 12 cups is equal to. So right now I'm trying to look for an easy multiplicative relationship to get from 16 to 12, and I don't see one, but I'm thinking of factors and multiplication, and I know that if I divide by 4, if I divide both sides of my ratio by 4, I find that 4 cups is equivalent to 1/4 or 1/4 of a gallon. And now that I know what 4 cups is equal to in gallons, I can get from 4 to 12 by multiplying by 3. Now, when I multiply both sides of my ratio by 3, I get that 12 cups is equal to 3/4 of a gallon. All right, we've arrived at our learning target for today's lesson. So let's see if we hit our mark. At this time, boys and girls, please pause the video and attempt this problem on your own. When you're done and you have your solution, please resume to check your work. All right, guys, welcome back. So I see that you've already done your problem. So now we're going to go through and talk about the solving process. We were given our perimeter of 6,615 feet, and we want to know what that perimeter is in yards. So the conversion factor, or the unit rate that I will be using is that there are 3 feet in 1 yard. So I'm going to set up a ratio table with feet and yards. I'm going to include the unit rate that I know, which is 3 feet for every 1 yard. And now I'm trying to identify how many yards it is for 6,615 feet. I see a very simple multiplicative relationship going across my ratio table by dividing by 3. So I'm going to divide 6,615 by 3. And I get 2,205. So my perimeter is 2,205 yards. Thank you guys for learning with us today.